Think of a creature that can survive 300-degree heat and 3,000 pounds of pressure, all without food or sunlight. Chances are you're thinking of a mythical creature or some kind of robot. Definitely not a snail, right? What if I told you that it was a snail, specifically an underwater snail, that survives these conditions and more? Scientifically known as the Chrysomelon squamiferum, volcano snails live by deep-sea hydrothermal vents in the Indian Ocean. These vents are rich in minerals and occur near convergent plate boundaries. These vents are 2,100 meters or 7,000 feet deep and can get up to 400 degrees Celsius or 752 degrees Fahrenheit. Even though that's way above boiling point, the water doesn't boil due to the pressure of the entire atmosphere above it. But how do the vents work? Water from the ocean cools and sinks and travels through fissures or cracks in the seafloor. As it moves through these cracks, it collects minerals and elements from within the sediment. These vents are so deep in the ocean, the water is then heated up by the magma that lies just under the oceanic crust, and the mineral-rich water is forced upwards and out of the seafloor. Once expelled from the vent, the minerals in the water cool and solidify, forming not only part of the vent called the smoker, but also helps form the scaly plates and the shell of the volcanic snail. These snails, that are about the size of a watch face, use iron sulfide compounds from the water expelled from the vent to form protective plates on their feet as well as their shell. These snails are the only known member in the entire animal kingdom to use iron sulfide as a skeletal material. The act of making minerals to strengthen existing tissues is known as biomineralizing and is exactly what these snails are doing. They have channels inside their shell that are supplied with sulfur that interacts with the iron ions in the water expelled by the vent. These two minerals combine and mineralize in the shell, forming the iron sulfide that helps make the snail's shell as strong as it is. In fact, the different minerals in the different areas of the sea they live in are what gives them the location-varying shell colors. Why do they need such protective shells? Scientists know of other dangerous animals that live in the same area, but assume the shell is for protection from predators rather than protection from prey that may fight back. After all, these snails don't have digestive systems, so what prey would they need to hunt? But if they don't have digestive systems, how do they get energy? Volcano snails get their energy from a process called chemosynthesis, which means to make energy from chemicals. It's similar to photosynthesis, but it doesn't use sunlight at all. Carbon dioxide, hydrogen sulfide, and oxygen are absorbed by specific bacteria that complete a chemical reaction to form sugar, sulfur, and water. These bacteria are either eaten or hosted by a larger organism that uses that chemical reaction for energy. In the case of our snail, they have a specific gland inside their body where the bacteria live and produce energy. As indestructible as you may think these snails are, they're actually labeled as endangered due to deep-sea mining near the hydrothermal vents that they rely on for survival. Once again, these snails are being recognized for something never seen before, except this time it's not for having an iron shell, it's for being the first animal labeled as endangered due to deep-sea mining.